So, uh, Alright guys, a train is moving in a straight line with uniform deceleration passes 3 points A, B and C 100 meters apart. Now, if you were trying, what I taught you guys in class, and you can replay any videos if you want, is that what I teach you guys is that you always start off, you use the common starting point. So I'm going to use AB and AC. Alright? I'm not going to devil with BC. I'm not going to do anything like that. I'm just going to keep it the same. Right? That's the method you're using. From now on, rest of your leaving cert, I've never, in all the leaving cert papers, I've never really had to defer from that method, okay? So just keep that method as your go-to when you see, I call these interval questions. So we have an interval AB, then followed by an interval BC. Now we're going to write down two data sets. Frozen. So we're going to write down a data set AB and a data set AC, okay? And we're going to UVAST them. U-V-A-S-T. Now the writing's very important. Do I start off as 0? It's the first thing I ask myself. Is there anything to indicate that I'm starting off as 0? No, it doesn't say rest, does it? So if it doesn't say rest, you assume you just have a value U. Now because they have a common starting point, AC has the same value. It's also U. The point of the question is the point of deceleration, so it means they both have a common acceleration. Now, S is 600 for AB and 1200 for AC. Are the times the same? Well, they're not. They're two different lengths, aren't they? So they're going to have two separate times. Is that clear, you guys? So, what do we need to do here? Okay, so we're going to go for... Actually, sorry, we know the times, don't we? 50 seconds from A to B, so that means 50 for this one. And then from A to C, it's 50 plus 70 to get you your 120. Okay? If you went for BC, you'd have to find out a new U value, and you actually can't do it, so there's no point going that route. Okay? Now we're going to use a UT plus a half AT squared. Why would I use that? The phi values are different, aren't they, in each question? The phi value for AB is how fast you're going across at point B, while the V value for AC is how fast you're crossing point C. So they're completely different, so you're not going to include V in any of your calculations. Okay? So the only formula that's left is S equals UT plus a half AT squared. Okay? And that's the logical conclusion. And then you got 600 equals UT, which would be U times 50 plus a half A times 50 squared. Okay, we're going to have 600 equals 50U. And what's 50 squared then? 2,500 divided by 2 is 1,250A. Divide both sides by 50, and you should get 12 equals U plus 25. Everybody cool with that? Alright, let's start off with AC then. So everybody happy with it? Let's try AC now. We're going to use S equals UT plus half AT squared again. So you get 1,200 equals UT, which is going to be U times 120, plus a half A times, now T squared is, anybody? 120. Go with that? UT plus a half AT squared. Alright. Now, 1,200 120U, and 120 squared, and then divide that by 2, and you should get 7,200. A. Alright, divide everything by 120, And we should get 10 equals u plus 68. Okay, you guys? Alright. Now, everybody see a standard simultaneous equation, yeah? I'm just going to give you the answer for the two standard simultaneous equations. Actually, they're fractions, so I won't do that. Alright, I'll take away the bottom one. Minus 12 equals minus u minus 25a. We're going to get 35a equals minus 2, and then a equals minus 2 over 35. Now, I know a student who had this answer, but he didn't find out the u answer for some reason. I don't understand why. So, we found out the answer to part 1. We reread the question, the deceleration of the train, right? I'm going to find out the u value anyway. So let's find out the u value. So u equals, I can bring over the 60a over the other side, so u will equal 10 minus 60a. So u equals 10 times 60 by minus 2 over 35. Put all that into the calculator, you'll find that your u value is 94 over 7 meters per second, alright? Now, do you remember what I told you guys? I always like to use the start, okay? Because I have all the information for the start, don't I? Now, when you read part 2, the distance travelled from C before the train comes to rest, I'm essentially expanding the track onto a point D. And what can I say happens at point D? At point D, the V value equals 0 and it comes to rest. Everybody cool with that? So I'm going to make a data set AD. When I find out the distance of AD, what do I need to do after that? So when I find out the distance from A to D, which is this distance here, the question only wants the distance from C to rest. So the answer is CD. We're trying to find out what CD is. So how do I find out what CD is? Like AD take away AC. And we know the answer for AC, don't we? 1,200. So my answer for AD take away 1,200. And you can see I don't have to do any messing around. I already have all my numbers. So it's going to be pretty easy. Right? So if I do UVAS for AD, this is the most seamless way to the result. Some of you has got the V value at point C and you worked it out that way, but I don't know why you would. It's slower. 0, A is minus 2 over 35. S equals, we don't know, that's the point of the question, we don't know what T is. Alright, you have two options, don't you? What's the first option? The long route. You use phi equals u plus at, and what do you find there? You end up finding the t value. And what you do with the t value? You throw it into s equals ut plus a half at squared. There's nothing wrong with that. That will work. Anybody give me a quicker route? Yeah, b squared equals u squared plus 2as. It's going to work all day long here. So, b squared equals u squared plus 2as, one formula, no worries. And we're going to get 0 squared equals u squared, which is 94 over 7 squared. 2as is 2 times minus 2 over 35 times s. Now, what did I do here? Oh yeah, I did all as one fraction. So, would everybody agree that's minus 4 over 35s? Everybody cool with that? Move it to the left. So you're going to get 4 over 35 s equals 94 over 7 squared. See that 4 over 35? So s will equal 35 is division on the right, which division on the left, which makes a multiplication on the right. The 4 is division on the left. Oh, sorry, multiplication on the left makes a division on the right. And you throw all that into the calculator and you get an s value. I got an s value of 1,578. Now, a few of you left this as your answer and you lost a few marks. Why did you lose a few marks? That's the distance from start to finish. You want the distance from C to D, so you have to take away here. 1,200, and you get 378 meters. Okay, so in this question, two particles P and Q move in the same direction along parallel lines past point O, accelerations 3 and 2 respectively. P passes O with speed 5, 1 second later Q passes O with speed 35. Find the greatest distance between the two particles. A big mistake a few of you made is which one's travelling for longer, P or Q? Is the first question I might ask you. Which one's travelling longer for a greater time? It should be in the description of the question. Come on, which one's travelling longer? 1 second later, Q passes O. This means P is already gone. So, P should be T plus 1, and Q should be T. Everybody okay with that? What other method could you use? You could use that as T, and that one as T minus 1. Your choice. Okay? The other thing that didn't make any sense either is that which one's moving faster? So, sorry, which one's moving faster is P passes with 5 and an acceleration of 3. Q passes with 35 and acceleration of 2. Alright. Here's the big one. Some of you said S1 equals S2. Or the distance covered by P equals the distance covered by Q. Is that true or false for this question? And explain why. I'll pause it. So, students sometimes get mixed up with two things, right? So if you imagine this is P and this is Q, P starts a second early, no bother. Q starts, they have a common starting off point. Q overtakes P. Only when Q is overtaking P is SP equal to SQ. However, what happens is it's the greatest distance between the two particles. Q flies off into the distance, P is following it. Q increases its lead until what happens? The velocity of P is the same as the velocity of Q. At this point, the distance stabilizes, and from that point onwards, P is moving faster than Q, so the distance will start to shrink. The distance between both particles will get smaller. Everybody cool with that? So, what you're not looking for is SP equals SQ. You're looking for phi P equal to phi Q. The time it takes for both velocities to be the same is the time it takes for the greatest distance to occur, because the gap is no longer getting bigger. All you need to do is use U plus AT for both. So phi P equals phi Q. Phi P is UT plus U plus AT. So it's going to be 5 plus 3 times T plus 1. Phi Q is 35 plus 2T. And then multiply that out, it's going to be 5 plus 3T plus 3. And that has to equal 35 plus 2T. 3T take away 2T equals 35. What's that? An 8, so minus 8. T equals 27. If somebody used a different method, you might have T equals 28. But what we're saying is we don't even need the T value is not important. So basically P is traveling for 28 seconds and Q is traveling for 27 seconds. Does that make sense? One of them's traveling for 28, the other one's traveling for 27. Now, we have to find the distance both of them have covered and then take away the distance from both of them. So let's see what distance both of them covered. So, we're going to need the distance covered by P. So, SP, so this is going to be UT plus a half AT squared. So UT is going to be 5 times 28 plus a half times 3 times 28 squared. Is this going to be bigger or smaller than SQ? Can anybody tell me? Prediction, bigger or smaller than SQ? According to the language of the question. Find the greatest distance between the two particles after Q overtakes P. So Q is further along the track than P. This would imply that SP is smaller than SQ. Okay? So let's find out. So, 1,316 meters. SQ starts off with initial velocity of 35. It's traveling for 27 seconds. Plus a half. 2 times 27 squared. Lob all that into the calculator and we get 1,674 meters. As predicted, SQ is bigger than SP. Take the two distances away from each other and you should get 358 meters. The largest gap is 358 meters. Okay. That is the 2010